everybody, Dr. A here, and in this video we're going to be providing some background information and exploring a simple example of how to analyze pulley systems. So let's go ahead and get started. A pulley system is a type of machine system that transmits tensile forces through a rope or cable that's wrapped around a set of pulleys. The force in a single rope or cable will always be constant and in tension, okay? Now, we see pulley systems all over the place, okay? So whenever you need to hoist something up in a convenient way, typically you use a pulley system. In workout and weight machines, there's typically internal pulley systems that make a workout machine work and function properly, okay? And so how do those look, when you see them? So typically you have a pulley, which is kind of like a round type of system or object, and it has a little track on the inside of it. And that track will have a rope or a cable threaded around it, okay? Now, if you impose a force on one side of that rope or cable, let's call that P, then what you're going to have is a constant tensile force throughout the entire length of that cable. So that means on the other side of that cable or rope, you're going to have the same magnitude P, because it's the same rope that's transmitting that same tensile force. And again, it's going to transmit specifically tensile forces. Think about this. Have you ever tried to push on a rope or a cable? Well, if you do, it's just going to crinkle up. It's not going to sustain any compressive forces, okay? And so when we think of pulley systems, what we could have is several of these pulleys, several of these circular pulleys, each with, a track on it. And again, they're generally circular. Sometimes you could see them as an oval, like I just sketched there, but usually they're a circular shape. And you could have, ropes or a rope, somehow maneuvering around all of them. Let me draw another one for us here to make it actually make a little bit more sense. Another one here, another one here. So again, these can get quite complex pretty quickly, right? You could have, this rope meandering around like such. And even when you have that, if you have a magnitude P on one side and it's one continuous rope, then that means you're going to have a magnitude P throughout that entire single length of the rope, okay? Now, usually these pulleys are restrained somehow, right? So let's say that we have some kind of restraint here. So you have maybe a link or something that is supporting this pulley to something else, right? Something on the exterior here, all right? So usually these pulleys have some kind of restraints, you want to make sure the restraints are not interfering with the function of the pulley. So it could be something like that. Again, just kind of sketching these examples. They could have all kinds of different geometries. Now, when we analyze a pulley system, we typically need to analyze a free body diagram of either the entire system or a part of a system, okay? So typically we analyze a free body diagram of part of or the entire system to determine unknowns. So the unknowns that you might determine maybe is a load P, maybe it's a reaction force, something like that, okay? So let's go ahead and jump right into an example of one of these and see what we can make of it, all right? So here in this example, we're being asked to compute the force P for the system to be in equilibrium. And then we're also being asked to find the reaction forces at A and B. And so here we have 3 pulleys, right? We have one here, a bigger one down here, and a smaller one here. And these higher elevated pulleys are attached to some kind of link, and they have some kind of support reaction. So we're looking for these axial reactions in these links as the second part of the question. Now we have a single rope that's wrapped around these pulleys, and it's rewrapped and connected back to itself. And then as we come down, we have this weight hanging off the bottom here of 30 pounds. Okay, so how are we going to analyze that? Well, we're going to start by saying solution. I'm going to write the solution to the right side here. And I'm going to say, let's look at a free body diagram of the lower pulley. Okay, so if I look at a free body diagram of the lower pulley, what am I going to look like? Well, I'm going to extract this right here. Okay, if I extract this portion of the system, then what am I going to have? I'm going to have that weight coming down here, and I'm going to have 3 forces coming up from that pulley. So let's go ahead and draw that out and see what we can make of it. So here's that lower pulley, okay, and here is the weight of 30 pounds. And then what about the rope itself, okay, or the cable? It could be a rope or a cable. Well, you're going to have the portion of the rope from either side of that pulley and the one coming off the center. Again, what I'm basically doing is looking at a free body diagram of what I'm circling here. So what do I see here? Well, I'm going to have the weight here, and I'm going to have these 3 forces coming off here. Now, what are these 3 cable forces? Well, that's what we need to look at the original system to figure it out. Notice that we have this rope with P hanging out here. And remember, we've got constant tension that wraps around here. So that means you're going to have P here. And then you're also going to have P wrapping around here. And then you're going to have P wrapping around here. And then finally, P here. And then, of course, you have W there. All right? So that's what we're seeing here. So what does that mean? That means that each one of these forces is P. Okay? Now, watch what I can do. If I say sum of the forces in the y direction equals 0, what do I have? Well, I've got 3P minus 30 pounds equals 0. And so what does that mean for P? P equals 10 pounds. And of course, that's a tensile load. Now, if P equals 10 pounds, now what I can do is look at a free body so that's part of my answer, right? Obviously, that's the first part of the answer. What is the force P for this to be in static equilibrium? So if we pull down with 10 pounds here, then this whole system, including the 30-pound weight, will be in equilibrium. That's great. But now we need to find the reaction forces at A and B. So what do you think I'm going to do next? Well, next, I'm going to look at a free body diagram of B. And I'm going to do the same kind of thought process with this free body diagram at B. So I'm going to go ahead and say look at a free body diagram of pulley near B. So when I do that, I'm going to have this pulley here. Excuse me, I still got some allergies I'm fighting with. Got this pulley here. That is not a pulley. I don't know why it's defaulting to a square. There. Okay, that looks reasonable, I guess. And I've got the rope hanging around here. And then I have this reaction at B, okay? Now, what are the forces in this rope down here, right? And we're looking at these 2 forces. Well, that's just these 2 P's, but going in the other direction. And we already know what those 2 P's are, right? So that's 10 pounds and 10 pounds. So here if we say sum of the forces in the y direction equals 0, then what am I going to have? Well, I'm going to have RB minus 20 pounds equals 0. And then RB equals what? RB is going to equal just 20 pounds. Okay, now what about my last step? What about the reaction at A? Well, I'm going to do something very similar. I'm going to look at a free body diagram of A, and I'm going to have what? I'm going to have P here, and I also have P here, and then I'm going to have RAY there, okay, or RA there. And so I'm going to say similarly, RA is also 20 pounds. And that's going to be the conclusion of my answer, right? I've got P is 10 pounds, RB is 20 pounds, RA is 20 pounds. And again, I didn't show my work for RA, but you follow along and you do it the same way. I encourage you to show your work for RA just to practice for yourself. So that's going to conclude this video on background information on pulley analysis, as well as this kind of short, simple example that goes along with it. Thanks for watching, and please don't forget to hit like and subscribe.